Hello, this is Alex Eames from RasPiO.tv.
Hello, in today's video I'm going to show you how to assemble the RasPiO Breadboard Pi Bridge. The PCB will require some soldering, and then the Perspex parts and the breadboard and the Pi all get assembled together, and the PCB acts as a bridge in between them. So let's have a look at the kit contents first. The kit comes in this bag, and you'll find all of the parts you need should be in here. There should be 3 Perspex parts, a PCB, a breadboard, and a bag containing all the other components. Inside the kit bag you've got a 40-way header for the Pi, 5 330 ohm resistors, 4 little rubber feet to give the whole thing a bit of stability, a 40-way single row male pin header. We only need 30 of those, but you get 10 spare. 5 different colour LEDs, 4 6mm M2.5 spacers, and 4 6mm bolts, 6 M2.5 nylon bolts, and 6 M2.5 nylon nuts, and a ground wire that will enable you to connect both grounds on the breadboard should you need to do so. Your Perspex parts will be covered with protective film, so at some point before assembly you'll need to peel that off. Okay, let's start soldering the PCB. We'll start with the Pi header, and then we will deal with the header to attach the breadboard. Now notice that on this side of the PCB it says top. The header wants to go on the underneath, so we place it down like that. And just to keep it nice and level, I'm going to use the other header, which is going to go here and also on the underside, and that just helps to hold everything nicely level. And there is a little bit of wiggle room on this header. Try to get it in the middle, and then everything will be really nicely aligned. It's not absolutely critical because there's a little bit of adjustment on the platform on the Perspex parts. You can tweak it a little bit, so I've tried to build in some flexibility there. So we'll do one corner to start with. Normally I would use a fan to extract the solder fumes, but that will wreck the video with a horrible noise, and you don't want to listen to that, so I won't do that on this occasion, which you might see me blowing vapours away because I certainly don't want to breathe them in. Okay, so we've done 2 corners. This is a good point to check that the alignment is good, because it's just about your last opportunity to make any changes. That looks pretty good to me. So I'm going to go ahead. Let's just put that there for balance. Okay. So I'm just going to whiz through doing each of these in turn and trying to stay away. This is a ground pin, so sometimes on the ground pins you need a little bit of extra heat before you apply the solder. If you find any of the pins more difficult than others, that may be the reason. This one coming up is also a ground pin. Okay, I'll do a few at the other end. It's not strictly necessary because there's nothing really connected to it, but if you were soldering it to a Pi or to another device with components attached to it, it's always a good idea not to do all the heating in one area at once because it can overheat areas of the board and damage components, but that doesn't apply in this case. I'm just showing you why I have the habit of doing a few at this end, then a few at that end. And we've got to have something to talk about, otherwise it makes for a rather a dry video. I always like to show full assembly on video. People can skip through if they don't want to see all the soldering, but the reason I like to do it is because it gives you a proper impression of how long it should really take. So to do this pin header 40 joints should take a couple of minutes really, but there's no need to hurry. Go at your own pace. It's much better to do it properly. As usual is my habit, I'm using 0.7mm leaded solder because this is for my own personal use. You're not allowed to sell products with leaded solder in, but it's much easier to actually use, so I prefer it when I'm soldering for myself. So since we've got this header in, let's start soldering that. We need a complete row on the underside, and that's going to join to the breadboard. So we'll do one pin, check that it's lined up properly, and it is, so that's great. Let's do one pin at the other end. Is it straight? Does it look right? It does. Excellent. Let's do the rest then. Blow that vapor out of my face. So these headers will connect each of the Pi's GPIO ports to one row on the breadboard. So none of these are ground pins, so they should all be pretty easy. Okay. Not sure I quite got that one as good as I would like. Oh, and that one I've probably overdone, but that doesn't matter. At the end of the day, it's not a vanity competition. The only thing that really matters is that there's a good electrical connection. And there you go. Right, now we can, and you can do this before if you want, at any time, we're going to just snap off the excess. Breaks off easily. and you've essentially almost finished. There's one more bit that we have to do and one optional bit. Next we're going to put 2 pins on the underside again into the ground and 3v3. They will connect to ground and 3v3 on the breadboard. I find it quite difficult to break 2s off without tools. Some people can do it, but reliably I'm much better off using a pair of pliers. So I'm going to snap off 2 of these. Excellent. And they need to go on the underside of the board, just like the rest. So at this point it's probably a good idea to use the sponge technique just to hold those in place. So what you do is you take a little sponge, like a dish sponge, that's what this is, just place it on top and then flip that over and it holds those header pins in place. Stops them falling out essentially. So what we're going to do is we'll solder the 3v3 pin first, then check the alignment before we do the ground pin. Okay, 3v3 pin is soldered. Is that straight? It looks pretty straight. Let's try it on the breadboard and just check. Does it fit properly? Don't push it fully in. Yes, good. That's great. The reason I say don't push it fully in is because what can happen sometimes is if the breadboard grips the other pin very tightly, it can pull it when you try to remove it, or you could finish it off with the breadboard in place, but that's fine. Everything's nicely lined up, so we'll solder up the ground pin. Excellent. If you wish, you can make use of the ground and 5-volt breakouts and put a pin header on those if you want to. It's optional and I don't think very many people will need it. My recommendation is just don't bother unless you need them. So the PCB is done, and that didn't take very long, did it? Quite easy too. Having soldered the PCB, what I usually do at this stage is get the magnifying glass out and have a good look at all of the joints, and I have to say they look okay. They look fine. So let's go ahead and put the rest together. Let's get the pie out and the perspex pieces and put the platform together. If you haven't yet done so, at this point you'll want to peel off the protective film from your perspex parts, because now we're going to use them. So you should have 3 perspex pieces. The largest is the base plate, the next largest is the breadboard platform, and the smallest is the pie cover. So if I show you the completed thing, you've got the base plate, the breadboard platform and the pie cover, and they all fit together like that. The way this is going to work is we have the breadboard platform, the breadboard with the flat edge here, so the red terminal should be at the edge. Don't stick it yet, but that's going to be there. These 4 holes line up with the 4 holes of the pie and the board, and so there will be 6 bolts through, 1 through each of these holes, and each one will take a nut. So let's start with the easiest bit. We'll do these 4 nuts and bolts first. So using a small crosshead screwdriver, let's do each of the 4 pie holes and do them up. Not quite completely, because we would like to have a little bit of movement, just so that we can get the alignment of the pie. So that's those 4 on. We'll place the pie on just to make sure we've got them pretty good. That's fine. Right, we won't tighten them up just yet because we want to put this piece on now. Take the last 2 of the long bolts and what I tend to do is try to use my fingers to make sure that those are lined up nicely. Now we've got the pie on as well. You'll notice I'm using a Pi 3B Plus here, and if you want to use the lid for the pie cover, then if you're using a Pi 3B Plus, you'll need to break off this tab and possibly rub the edges with a little bit of sandpaper. But before we actually use the pie lid, we need to attach the breadboard, and before we attach the breadboard, we need to put the spacers on to hold the pie firmly in place. So there's a little bit of a knack to this, but the best way I've found of doing it is to use the screwdriver to back out from this nut, and you back out until the spacer sits flush, and then you drive the screw in through both the nut and the spacer at the same time. See how that works? Okay, let's do it again. Let's do it again with this one. So you put it on to get the alignment correct, then you back out using the screwdriver until the spacer sits flush, then you drive the bolt into both the screw and the spacer at the same time. And then let's do that for this one. Whoops. Be careful of your nylon components. You do not want to have to find them in the carpet. Okay, same as before, back out and then drive in through both at once. If it doesn't want to go all the way in, you can try again, but that's worked out well. Okay, to be honest, you don't really need to use all four, but there's four, so I'm going to show you how to fit four. Okay, so we've backed out, that's sitting flush, and we're going back in. Now that one hasn't gone on very nicely, so we'll probably slightly cross-threaded, so we'll hold it a bit firmer, and that's worked better this time. See, that's quite a difficult job to do if you haven't got the screwdriver. There's a little bit of wiggle room, as you can see, which gives us a little bit of flexibility in case this PCB hasn't been soldered on quite straight. Hey, we're getting there. We're getting there. Next up, we want to put the breadboard on here. And in order to get the alignment of that, we're going to use the Breadboard Pi Bridge. So the first thing we're going to do now is put the Breadboard Pi Bridge PCB onto the breadboard. We want to make sure that the positive rail, the red one, is towards the PCB, towards where the Pi will be. This end goes to the breadboard, this end goes to the Pi. And these two pins, that one goes to positive, that one goes to ground, at this end, in the top. So, see that? So this top pin here goes in the top row, and if we've got everything right, it should just press. Might need to press quite firmly the first couple of times because new breadboards can be a little bit tight. But that's what it looks like when it's done. And now what we're going to do is trial fit that on the Pi, and it looks as if that's going to work nicely. So at this stage, before we press firmly down, let's peel off. Let's first make sure that the alignment of these two pieces is good. You can do that with your fingers and feel that everything's lined up. If it's not, you can undo these bolts very, very slightly and just wiggle, because once you stick the breadboard on, you won't be able to move it to make any more adjustments. The breadboard and the pie bridge will determine a permanent position. So this is your last chance to get the alignment as you want it. This one is lined up really nicely, so I'm just going to peel off the backing of the breadboard and then connect that onto the pie header, squeeze at both ends alternately, and then squeeze the breadboard, and that is now stuck. Splendid. You now have a bridge between all of the GPIO ports on the Pi and the breadboard. So now let's fit the Pi cover. If you're not using a 3B+, you can leave this tab on. If you are using a 3B+, it needs to be broken off so that you can get round the power over Ethernet pins. The way that you break off the tab for the Pi 3B+ is you firmly hold the Pi cover with one hand and have a decent pair of pliers in the other and just twist them apart like that and throw away the bit you don't want. But as you'll see, there are a couple of little lugs left over. If you want to be nice and safe, what you could then do is get a piece of sandpaper or a small file and just rub those down. Now we've got the breadboard stuck on, I'm going to show you the best way to remove the PCB. It is quite tightly onto the Pi and quite tightly onto the breadboard, and the way I envisage this product being used is that people will pretty much want to leave them like that, but it's not completely irreversible. If you wish to remove the breadboard Pi bridge from the Pi and the breadboard, if you take something like this wooden skewer and just gently prise up a little bit on each side, that will be the safest and easiest way of removing the board from the Pi. It'll take a few iterations, but it's worth being patient to avoid bending the pins or bending the pins on the Pi. So it's easier to attach the Pi cover when the breadboard Pi bridge PCB is not present. So now we've got our lid ready. That's what these remaining 4 bolts are for. Obviously the 4th bolt won't really do anything on a Pi 3B+, but that's fine. To be honest with you, 2 is actually enough. So 3 is good and 4 is just, well, overkill really, but that's fine. You've got 4 if you're using anything other than a B+ and you want to use them. And if you like symmetry and you want to know where to keep, where you kept the last one, you could even put that there if you wanted to, but that's just big silly. Okay, so now let's pop the bridge back on, and if everything's gone as it should, that should, as long as you line it up properly on the Pi, it should automatically have been lined up with the breadboard as well. And that is how it is. Look at that. Now you've assembled your breadboard Pi bridge kit. Next, let's put the ground wire on and put some components on the board and test it, shall we? In your kit you should have a piece of black wire like this. Now this is going to join this ground rail to this ground rail, and what we need to do is we need to strip off a little bit of the insulation at one end to start with, probably about 5mm. I've got wire strippers, but I'm not assuming that you've got any, so I'm just going to show you how easy it is to do with a sharp knife. You just spin the insulation around on the blade and pull like that. Then we're going to stick that end into the ground rail, bend across, and see how far we need to go. So you've got, that is the point at which the other ground rail is met. We need to strip the insulation from there, but it's easier if we shorten it. So let's make the length of this wire about 5 or 6 millimeters longer than necessary according to that measurement. Then what we need to do is strip the insulation from the end like we did before and plug that in and plug the other end in, and we should have a nice neat connection. Hurrah! Now your ground rails are joined. Now we've got the ground wire done, let's put the rubber feet on the base. Let's flip over the whole thing and attach the rubber feet, one in close to each corner. This should give it a little bit of extra stability. They should just easily peel off the strip of 4 provided. And go at or near the corners. I'm sure you can do a better job of it than me. It's now level everywhere and won't move about or slide off a sloping surface. So now the rubber feet are on, it's not slipping or sliding anywhere. Let's add some components to the breadboard and test it. Now let's connect up some components and give the board a test. So we'll connect up this LED. The longer leg is positive, so we'll connect that to GPIO2. The other one goes across to the other side, and then we'll take a resistor from the pack, 330R, and connect that to the ground rail. So once you've finished that and done it neatly, it will look like this. And now it's time to run a little program. I'll give you the details of that program as well. Using GPIO0, we're going to see if we can light the LEDs. So this is what it looks like when the code is running, and I will share the code with you. But basically it's just very simple, GPIO0, and we're flashing each LED in turn. The LEDs are connected to, red is port 4, white is 10, green is 16, blue is 21, and yellow is 27. But you can change the numbers to whatever you want. So if all that's gone according to plan, your RasPiO Breadboard Pi kit should now look something like this, and it should be working. I hope you'll have a lot of fun with it, and thank you very much for buying one. This was Alex Eames for RasPiO.tv and RasPiO. Thank you for watching.